So today, we're going to be talking about the sun's next solar cycle. Due to early detection of it right now, it's expected to start in 2030, but we've already got some signs of what it's going to look like. In the sky report, we'll talk about how the moon is going to be intertwined with other planets in the night sky as we look at them towards the end of this week, Wednesday night, all the way up to Friday. Finally, we're going to be talking about Europe's new satellite launch expected to launch in 2026 with the purpose of searching for exoplanets that might be able to support life. All that and more will be covered. This is Interstellar Insights. Alright guys, so to start out this week's episode of Interstellar Insights, we're going to go back to kind of a topic I believe we kind of talked about on episode 1 regarding solar storms, but that was more about the future and the forecast of solar storms, throughout the years, because right now we are at a solar maximum, which is kind of like the climax of the cycle, where there's a lot of solar activity, a lot of, sunspots, solar flares, CMEs, coronal mass ejections going on in the sun right now. But that episode was mainly about upcoming storms. Recently, after that episode was posted, I think about a week ago, I believe, or a few days, there was new data regarding early detection of the next solar cycle that's going to happen. So, to give you a rough time frame, right now we're in this solar maximum phase of the current solar cycle, which is cycle 25, because this is the 25th cycle that's been recorded since 1755, as that was the first time these cycles were kind of recorded, and I believe each solar cycle lasts about 11 years. So yeah, cycle 25. But anyways, right now we're in the solar maximum part where, like I said, there's a lot of solar activity going on right now. And this is going to carry out until mid-2025, where it'll kind of reach a solar minimum. And then it'll continue. And at a solar minimum is when there's not that much solar activity, very minimal, just the opposite of a solar maximum. So yeah, that's when the solar maximum is expected to end in mid-2025. And then following that, it's going, like I said, down the solar minimum. And then its next cycle, it'll kind of fizzle out from there until 2030, where cycle 26 is expected to start, which will be the next cycle. Like approximately 2030. And yeah, so right now, from that evidence, we can already see, understand the patterns that will emerge from this, mainly because there's so many intricate parts involved in the solar cycle, mainly, plasma and the magnetic fields. Because I should have mentioned this earlier, but at every solar maximum, the poles of the sun will flip, which leads to, your lots of electromagnetic energy being ejected out into space by the sun. Sort of like those solar storms I was talking about from, I'm going to say it's episode 1. Episode 1, when we talked about the solar storms, that occurs at the solar maximum. So yeah, that's what's going on there. And then I once again, I probably should have said this earlier, but solar cycles are just 11-year cycles that are when sunspots, solar flares, coronal mass ejections, they all kind of fluctuate at, different frequencies and different energy levels. So like, with the maximum, they're more likely to happen. They're at its strongest. A lot of energy is being ejected from the sun out into space, towards us. Solar storms, you get it. And then like solar minimums, there's not that much solar activity going on with the sun, where, there's not as much electromagnetic energy that's being ejected out towards us. And like I said earlier, poles will flip every 11 years, which, affects the sun's magnetic field, polarity, stuff like that. That's what happens. But yeah, and then, solar cycles, observing them are very important, because then, it helps us gain a better understanding of the sun and, solar weather, and, helps us analyze these sunspots, solar flares, and coronal mass ejections. So yeah, that's what I've got on the sun's new solar cycle. Like I said, this is kind of a update towards the first episode, and I believe in that episode I said that there might be some stronger solar storms, stronger solar weather headed our way. Within the next few months, a lot of electromagnetic energy heading off towards us. So hopefully I can get more updates on that. This is kind of a topic I think I'll follow up more occasionally because, it's important. It's always changing. So yeah, that is updates on early detection of what could be cycle 26 expected to start in 2030. Yeah. So yeah, and next few episodes, we'll see if there's any updates regarding solar weather and, detection. So yeah, that's all I've got for this topic. Let's go move on to the Sky Report. All right, guys, so let's get into this week's Sky Report. Reminder that all times, unless I specify on Eastern Daylight Time, so if you don't live here on the East Coast, go do the math, figure it out yourself. But anyways, let's get right into it. We're going to start off with Wednesday night. So I ended at this earlier in the intro, but a lot of the stuff that's happening kind of at the end of this week, kind of this like 3-day forecast, if you will, it has to deal with a lot of planets and moons. Mainly tonight and tomorrow, the moon's going to be kind of intertwined with planets. So, for example, today or tonight, the moon's going to pass Saturn 0.4 degrees north at about 5 p.m. That's expected for those who are living in Southeast Asia, but other observers might be able to catch it at midnight because Saturn is potentially rising at 10:30 p.m. But this is dependent on your location, like I said earlier. So if you want to take a look at this, check it online. I can't report all of that. But anyways, Saturn is going to be at a bright 0.8 magnitude, and other moons such as Mimas, Enceladus, and Rhea are going to be transversing Saturn's rings, so they're kind of dancing around it, along with our moon, of course. So that is what is happening tonight, Wednesday. Tomorrow, 25th, Thursday, the moon, once again, is going to pass this time, not Saturn, but Neptune, 0.6 degrees north at about 11 a.m. And Neptune is going to be rising 11 p.m. local daylight time. So I believe that's going to be local daylight time sometime. That doesn't really make sense, but local daylight time potentially not next day. How about whatever? I'm getting myself too caught up. Anyways, Neptune is actually going to be pretty dim compared to the moon when it passes it. It's going to be at a dim 7.7 magnitude, and unless you got a pair of binoculars or a telescope, it's going to be very hard to spot in the night sky with just the naked eye. But anyways, the moon itself is actually going to be pretty bright. It's going to be 72% lit, and since the moon is obviously super close, a lot of the moon's features are also going to be viewed, such as the Sea of Serenity and one of the moon's big craters, Copernicus, is going to be visible. And yeah, that's what we're going to see from the moon and Neptune on that night. I guess it is at night. I don't know. These timings are kind of strange. But anyways, that's what's going to happen Thursday. Anyways, Friday. Friday's the only day where we don't really see much of the moon. But in the early morning, about 30 degrees high in the horizon before sunrise, Taurus, the constellation, is going to be up. And it's not going to have just one planet, not two, but there's actually going to be 3 planets within the constellation that you can see in the night sky. Those planets are going to be Mars, Jupiter, and Uranus. And Jupiter is going to be the easiest to spot as it will be shining with a magnitude of negative 2.1, which is really, really bright. Mars is going to be the second brightest, shining with a magnitude of 0.9. And Uranus is going to be the dimmest. I'm not saying that visually it's going to be dim, but out of the 3 planets, it's going to be the least brightest. Uranus will have a magnitude of 5.8, and this is kind of a trend going on in the night sky, but when you find Mars and Uranus, they're going to be pretty close. And I don't know if I covered this from Sky Reports in the last week, but they were actually in a conjunction for a while, very, very close to each other. So right now, they're on a path to being separated. So yeah, they're right now 7 degrees apart, and they're still going to separate throughout the following weeks. Because I think it was like 2 weeks ago, they were at a conjunction, and now they're just totally separate. So yeah, that's what's going to happen. Friday morning, nothing happening that night. So wake up in the morning and take a gander at it. But anyways, your times for this week are, tonight, Wednesday, 24th. Sunset's going to be at 8:21 p.m. Moonrise is going to be at 10:38 p.m. and moonset's going to be at 9:31 a.m. Tomorrow, the 25th, it's going to be 5:53 a.m. for your sunrise, 8:20 p.m. for your sunset, 11:02 a.m. for your moonrise. Actually, no, my bad. 11:02 p.m. for your moonrise, and then your moonset's going to be at 10:45 a.m. And then for Friday, the 26th, your sunrise is going to be at 5:54 a.m. Your sunset's going to be at 8:19 p.m. Your moonrise is going to be at 11:27 p.m. and your moonset's going to be at 11:59 a.m. And the moon phase for this week, you'll see this as you were looking for at the moon on tonight. Yeah, tonight. I don't know why I'm saying it like that. Tonight, Wednesday, and Thursday. It's going to be a waning gibbous moon. It's going to be like that. Hopefully, we get to see a full moon sometime in August. Yeah. So yeah, that is this week's Sky Report. Let's go move on to the next segment of this episode. Alrighty, guys. So our last major topic that we're going to talk about today kind of ties back in I believe it was last week's episode where we were talking about the new exoplanet that was discovered. That was like a water world in a planetary system with a red dwarf that was like in the Goldilocks zone for supporting life. This topic's very similar, although they're not really connected. But it's about the new telescope that's going to be launching from Europe, called the Planetary Transits and the Oscillations of Stars, just abbreviated down to PLATO, which is being launched by the European Space Agency, or the ESA, of course, the primary space agency for the EU. Because it's with the EU, it's technically an intergovernmental organization, which is kind of a fun fact that if you want to flex on your friends, you tell them that. But anyways, this telescope, PLATO, like I said, tying it back in, is actually going to be used to find exoplanets, around sun-like stars that are within the habitable zone, or the Goldilocks zone, as some of you guys might know it, that could potentially support life. So, like I was talking about, stars like the sun, medium-sized stars, or even like red dwarfs. Because I think, personally, red dwarfs are the best bets in terms of candidate stars for finding planetary systems that can support life, because red dwarfs can live so darn long because they've only used, they burn so little energy. They've only used, I believe, 1% of their fuel, and that is, 1% for the whole time the universe existed, which is very amazing. Definitely, I think the best places to look for in terms of finding planets that can support life. But I'm getting sidetracked by that personal opinions on stars that can support life. But anyways, the technology is pretty cool. So the Mullard Space Science Laboratory of University College London is designing these cameras, and the satellite's going to have 26 of these cameras that'll give the satellite, it'll give PLATO a very large field of view, which is going to be very beneficial as it looks into the night sky, detecting exoplanets. And so with that being said, part of the strategy that the ESA has devised for tracking these exoplanets is going to be that they're going to be looking at two parts of the sky simultaneously. So I believe they're going to be looking at an area of interstellar space, night sky, in the north, and one in the south. So they're going to look at those two simultaneously as they scan for potential exoplanets in the night sky. So right now, Plato, kind of coming off of these costs, Plato currently costs 4 billion euros, which is approximately 4.3 billion US dollars. Building and developing, that's like I said with the cameras, the rocket, stuff like that, that's going to be used in order to get Plato into space, and so that Plato can use to observe exoplanets in the night sky. So with that being said, Plato is expected to launch December 2026 on the ESA's new rocket, the Ariane 6 rocket, I believe that's how it's pronounced. And that rocket itself is pretty new. Yeah, I believe Ariane 6 took its maiden flight last week. So, because we need a rocket to get that satellite up in space, or else it'll just sit on the ground. Anyways, that new rocket was tested. Clearly, it works. It's functional, operational for them to use for this mission. And yeah, so as they develop the actual satellite and then integrate the camera technologies that I talked about, that'll take, right now it's 2024. So we're still 2 years out from this project, and like I said, the camera technology is being built and tested by the Muller Space Science Laboratory. And yeah, we're going to see a launch sometime at the end of 2026. And hopefully this satellite's operational and we can find, exoplanets with life out in interstellar space. So yeah, that's what I've got for this new telescope. Potential launch, a lot of the stuff in the news is regarding Artemis 3, which I believe is launching about the same year as this telescope, and SpaceX mission to Mars or whatever. But there's still other stuff going on in the world that deserves recognition, and I believe that this Plato satellite by the ESA is, very deserving, because it'll help us find where else can we habit, or where else can life potentially be. So yeah, that is what I've got for this topic. So let's go and move on to this week's edition of Astronomy Trivia. Alrighty guys, so let's get into this week's edition of Astronomy Trivia. Before I reveal the question for this week's poll, submissions, whatever, we're going to talk about the answer from last week. And I believe the question was, what is the program that the Soviets created to study Venus? I believe that was the question, or something along the words of that. And in that case, the answer is going to be the Venera space program. So we'll talk about that quickly. So the Venera space program, and Venera is literally just Russian for Venus, just straight up. It was a space program that was developed by the Soviet Union between 1961 and 1984, which basically gathered information all about Venus. So compared to America, the Soviet Union did a lot more with Venus, because I believe the only probes that NASA sent to Venus were mainly Magellan, which just orbited it and looked through its dense atmosphere, and Messenger, as it was in transit from Earth to Mercury for that mission, and even maybe Mariner 10. But anyways, the Soviets were a lot more focused in Venus, so they did a lot of firsts, if you will. So, Venera sent a probe, for the first time into Venus's atmosphere, which was Venera 3 in 1966. It was the first to land on Venus, which was done by Venera 7 in 1970, and it was the first to take images of Venus itself. That was done by Venera 13 in 1981. And a lot of those images you see of the surface of Venus, like the actual images, not like artist renditions, come from the Venera space program. Like I said, Venera 13 was the most notable. And yeah, so this program saw, a lot of successes and failures. Mainly more failures and nothing to do with the technology or anything, but it was mainly due to the extreme conditions on Venus, because Venus is super hot. There's, I believe, acid rain and sulfur volcanoes, which can do a lot of damage to, the spacecraft as they land. So a lot of these probes maintain contact with Earth for up to a few minutes to, I'd say, maximum 2 hours. So yeah, I feel like this space program is a lesser known feat by the Soviet Union during the space race. People say by the time of the Apollo 11 landing, the Soviets kind of dropped out, but then they managed to get pictures of Venus and land on Venus, but NASA wasn't able to. They just didn't invest time to that. Although, to be fair, NASA sent out Voyagers 1 and 2 during the time of this program, so there were more, I guess it was just more interest than at that point. But yeah, so yeah, that's the Venera space program. That is really the only major space program in the world that we've seen land or take images of Venus. So yeah, that's last week's answer. Let's actually move into this week's question, which is going to be, what is the nearest known star to the sun? I want to say that again. What is the nearest known star close to the sun? Yeah, and by that I mean just nearest star that is close to star, straightforward. But yeah, that's your question. I will put the poll out right after, probably sometime when this episode is posted, both on Spotify for my Spotify listeners and on YouTube for those that are listening through YouTube. So yeah. Now, with that being said, let's go and close out this week's episode. Alright, guys. So, thank you for listening to this week's episode of Interstellar Insights. Next week is going to be a regular week. Nothing funny, a regular song and dance. So, yeah. Everything's going to be normal. New episode next Wednesday. So, yeah, if you enjoyed this episode, feel free to give me a like and subscribe, or like and subscribe. If you're listening from YouTube, it really means a lot, helps me grow, and helps me make new content. And speaking of new content, besides this regular podcast, I'm thinking of starting to post shorts and long form content that's going to be outside this podcast, related to astronomy, that'll kind of help diversify what we talk about and stuff. So yeah, expect something. It's going to be unscheduled. It's not going to be on a fixed schedule like the podcast, but it is good kind of supplementary content that I will put out there. So yeah, if you want to stick around for that, 100% subscribe. And yeah, like I said, like and subscribe if you're listening on YouTube, or if you're listening from Spotify, go ahead and hit me up with a follow. So yeah, that's all I've got for you guys. This is Michael signing off.